All right, so this last video is just going to be some worked out examples that might help you with your homework. So if you want to try them on your own and then look at the solutions, that's probably the best way to go about it. But I would recommend looking at this first before you start your homework. Okay, so here's the first example. And by the way, there's going to be 5 examples altogether. Here's the first example. So if you want to pause the video and try it, you can. But I have it worked out right here. So let's take a look. First of all, you want to always solve the equation for the squared part. So in this case, because x is squared, that's why I got that by itself. So I'd have to divide by 2 and I get 1/2 y. So the x is squared, that means it's got to be opening up or down. Because it's positive 1/2, I know it opens up. And then 4p is always going to be this number. So 4p is 1/2, that means p has got to be 1/8. So remember what I was saying in the previous video. Don't try to memorize all those formulas I gave you. Just think about the relationship of everything. So the vertex, we know, is at 0, 0, because it's not x minus anything or y minus anything. So h and k are both 0. And then it's opening up, so the focus is going to go up from the vertex. That means we're going to take the y-coordinate and add 1/8, add p, and we get that. And then the directrix goes in the opposite direction, so we take the y-coordinate and subtract. We get y equals negative 1/8. And then the length of the lattice rectum is always going to be 4p, and we have it right here. 4p is 1/2. And from there you can get the graph. So the vertex is at 0, 0. I went up p units. And by the way, notice my scale, because all these numbers were so tiny. I made every 4 squares equal 1. So that means each square is worth 1/4. So that means 1/8 is actually half a square. So I went up 1/8 of a unit for the focus, and there's 0, 1/8. I went down 1/8, and there's the directrix at y equals negative 1/8. And then remember what I was saying about the lattice rectum, that can help you find other points on your parabola to tell you how wide to make it. So the lattice rectum has got to be 1/2, and using my scale, that means 2 squares. So I'm going to go half of that to the right and half of that to the left from the focus. That gives me the lattice rectum right there. And that helps me with my parabola. So if you want to draw that in there, that blue dotted line is the lattice rectum. And so I didn't calculate these at all. I just counted 1/2 unit to the right and 1/2 unit to the left. Or half of p, I should say. Anyway, half of 1/2. There we go. Half of 1/2, which is 1/4 to the right, 1/4 to the left. So there's example 1. Okay, so example 2. So this is example 2. And again, it's very similar to example 1. So if you didn't get number 1, you might want to try this one. So pause the video if you want to. And, whoops, here it is. So again, we have to solve for the squared term. This time y is squared, so we move the x term to the other side, so we get y squared equals negative x. Since the y is squared, it's going to open left or right, and then because it's negative, we know it's going to open to the left. And then 4p is 1. Remember, p always has to be positive because it represents a distance. So I ignore the negative here, and there's just an invisible 1 in front of x. So 4p is 1, that means p is 1/4. So from the vertex, I'm going to go left p units for the focus. And that's why I take the x-coordinate and subtract p. And there's my focus. And then for the directrix, I take the x-coordinate and add p. And there's my directrix. And then the length of the lattice rectum is always going to be 4p. So it's going to be 1. So here's my graph, and again, just because of the numbers, I chose to use the same scale I used above. I made every 4 squares equal 1, so each square is 1/4. So starting from the vertex at 0, 0, I went left 1/4 unit for the focus and right 1/4 unit for the directrix. And then because the length of the lattice rectum is going to be 4p, which is going to be 1, which is 4 squares, then I'll go 2 units one direction, 2 units in the other direction for my lattice rectum. And the entire length of my lattice rectum is 1. So there's example 2. All right, so now example 3. Whoop, sorry. Hope you're not getting dizzy. So there's example 3. Same kind of problem, but this time it's written differently. So we're going to have to complete the square on this one. So we saw how to complete the square before. We reviewed it when we did circles. So you guys want to try it now, and let's go ahead and do it together. So this time for parabolas, there's only one coordinate one variable that's squared, and it's just the y. So I got the y's on one side and I got the x's on the other. And I could have moved the x's over, but I chose to put the y's over because remember, when you complete the square, the coefficient's going to have to be +1. So I moved these two terms over to the other side of the equation, but just chose to write it on the left side. But these terms didn't really move, so they didn't change sign. So I have this, and now I'm ready to complete the square. I don't have to factor anything out because my coefficient's already 1, so half of b squared is 1. But whatever you do to one side, do to the other. And so then we combine our like terms, and we get -32, and then we just have to get the coefficient of x to be 1. That way we can see what 4p is, and we can also see what h and k are. So now the y is squared, so it's going to open left or right. It's a +4, so we're going to open to the right. And then this is 4p, so 4p is 4, that means p is equal to 1. And then we got the vertex. Now be careful with the vertex here because it's easy to just mix up the x and the y coordinates, but h is always with the x. So that's why 8 is my x coordinate, and k right there, 1 is my, or -1 in this case, is my y coordinate. So there's my starting point, there's my vertex, and then I'm going to go to the right p units for the focus. So that means I'm going to take my x coordinate and add p, and then I get my focus. But I'm going to take my x coordinate and subtract p to get the directrix. And this is all happening to the x coordinates, so that's why it's x equals 7. So hopefully that makes sense. And then as far as the graph goes, graph is pretty easy now. So the vertex is at 8, -1. Oops, sorry, there's the vertex is at 8, -1. The focus goes 1 unit to the right, the directrix goes 1 unit to the left, and then to get my other 2 points, I know the lattice rectum is going to be a length of 4, so I'm going to go 2 units one direction, 2 units in the other, so that the entire length of the lattice rectum is 4 units, and then that tells me how wide to make my parabola. Alright, so 3 down. Now the last 2 are going to be given information, write the equation. So here's this one. And again, if you want to pause the video, go ahead and let's go ahead and look at it together. So we find the vertex and we find the focus. Some people can visualize it in their head. I like to just do a quick little sketch. I need to figure out which way this thing is going to open. Is it opening up, down, left, or right? Because I need to know what the basic form of my equation is going to be. So I just do a quick sketch. It doesn't have to be as accurate as what this one is, although the parabola itself is definitely not accurate. But I just need to know, okay, the vertex is there, the focus is down from the vertex. Ah, got it. So that means it's going to open down. And then I also have a visual to help me see what P is, because remember, P is the distance from the vertex to the focus. So I can see that P is 3. And then it already gave me what the vertex is. So if it's opening down, that means that the x has to be squared, and it's in the negative direction, so it's -4p. So now I know my basic form, and then I just have to fill in everything. So h and k, h is -1, k is +2, p was 3, so -4 times 3 is -12, and we're done. So it's really nice. And the last example. Here is the last example. So again, if you want to pause it, go ahead. And let's go ahead and take a look. Okay, so this time it gave us the focus and directrix. It didn't tell us the vertex, but we know if the vertex or focus is here and the directrix is here, the vertex is going to be halfway in between. So again, I just do a quick sketch to help me visualize which way this thing is going to open, and then it also helps me visualize what I'm working with. So here's my focus at 2, 4. My directrix is a vertical line, x equals 6. I know that it's going to open away from the directrix, so it's going to open to the left. And then my vertex is halfway in between, and this was nice to see, so I can go ahead and see that my vertex is at 4, 4. And then I can also see easily what my p is. My p is 2. And then it's the same thing as before. It's opening left, which means the y has to be squared, and left is the negative direction. And then I fill in my h and k for my x and for my vertex, and then p was 2, so -4 times 2 is -8. And there you go. All right, so that's parabolas in a nutshell, and I'm going to leave it up to you now. Bye.